Here's another exciting project that we're going to have the students do, and that is to design a gear computer. Now, probably they know about gear trains. We'll review that, and we'll design a gear train such as the one shown here. It just is a simple gear train with a lever and a ratchet system. But what I'm going to want them to do is to design a gear multiplier. In other words, for this particular gear train, for every time I turn the input, for every complete revolution, the output turns, I think, 41.67 times, almost 42 times. So if I want to use this as a multiplier, it's just the number of turns. Let's say I turn it twice. Twice on the input will be almost 84 turns on the output. Seems fairly straightforward, but what I'm going to want students to do is something a little more challenging. Now, what I'm going to want the students to do is to figure out a way to get the information from this gear computer over here into the LEGO Mindstorm's NXT processor. One way to do it is to build an encoder. Here's an example of a encoder. All it is a paper disc, and what I'll use is the color sensor from the Mindstorm's kit to read this disc, to read the transition every time it makes a transition from white to black as I turn the crank. What that will do is, through a program I wrote, it'll register it on the computer, and that's how we'll get the data from our gear computer into the NXT computer. There are many ways to do this, and what I'm going to do is challenge the students to figure out a way. Let me demonstrate the gear computer with the encoder disc. Okay, now what I've done is I've turned off all the ambient light. We have our color sensor here, which is going to read the rotations of the disc as I turn this for one revolution. Perfect. At one revolution we should have 41.7 or 42 rotations. Now if I wanted to multiply that by 3, what would my answer be? 126, right? So let's see if we get that. So we have one rotation, we're doing a second rotation, and here we come with the third rotation. Well, close. 122. Pretty close. Let's see how you can do.